In section 5.9a, you're going to simplify powers of I, add, subtract, and multiply complex numbers. So to add two complex numbers, first I'm going to write over on the side here 2x plus 1 and then 3x plus 2. Okay, this doesn't have anything to do with i's, but it's very similar how you combine like terms. So this has a 2x, this has a 3x. We say they both have an x. We're going to add the coefficients, so that's going to be 5x. Neither one of these have an x. They're like terms, so we're going to add that to make plus 3. To add two complex numbers together, we add their real parts, or the parts without the I. Then we add their imaginary parts, or the parts with the I. Okay, so for example, some people think that this is a multiplication problem. No, it's not. These are in parentheses here because this is one whole number here. You have a real and an imaginary part. So we're going to add the parts, and what you can do, let's just do this. Let's just line them up right down underneath the other. So this is going to be 7, that's without the i's, and then minus 6i. Okay, so that 4 plus 7 is 11, and 3i minus 6i is going to be minus 3i. Now, to subtract two complex numbers, you can take the opposite of the terms that follow the minus sign and just add like you did before. So here we can line up. Let's just do this one in a straight line. Now we'll have 4 plus 3i. We're going to take the opposite of everything in here, so this would be minus 7 plus 6i. And now we'll combine the 4 and the minus 7, so that's going to give us a negative 3. And 3i plus 6i is going to be plus 9i. All right, now, to multiply complex numbers, you multiply by distributing using FOIL. You combine, or this should be an OR here. Combine like terms, change all I squared terms to negative 1, and write your final answer as A plus BI. Okay, so let's go ahead and multiply here. We have 12i minus, this is going to be 18, so 3 times 6 is 18, and then I squared. Now, anytime you see an I squared, we're going to change it to negative 1. So let's change this right here to negative 1. This becomes 12i, negative and a negative becomes a positive 18. And so we changed all terms, I squared terms to negative 1. Now we have to write our final answer in the form of A plus BI. So we're going to write 18 plus 12i. This is foiling, so you're going to FOIL just like you did before. That's going to be 12 minus 3i plus 24i, and then minus 6i squared. Okay, we can combine the two inside terms, so 12 minus 3i plus 24i is going to give us plus 21i. And then over here, this I squared is going to change to negative 1. So basically, anytime you see an I squared, you're going to take the opposite of whatever this term is, because it's a negative and a negative. So that's going to be a plus 6. And now we're going to add like terms. No i's get added together. And then we write the i's. Okay, so that's multiplying. Now, the other thing that you're going to do is you're going to simplify powers of complex numbers. The power of I should never be higher than 1. So here is a pattern, and you can probably see it goes I, negative 1, negative I, 1. And then it goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. So every 4 powers of I, the powers of I have a repeating pattern that allow you to express any power of I, one of 4 values. It's going to be I, negative 1, negative I, or 1. So you can remember the phrase, I won, I won. And I don't know what you win, but with the negatives in the middle to help you remember the pattern. So I, 1, I, 1, negatives in the middle. This is I to the first power, I to the second power, I to the third power, and I to the fourth power. So anytime you see one of these powers, you change the i's back to this. All right. We have 14 i's here. So anytime you, let's go back up to here for just a second. Anytime you have 4 i's, 1, 2, 3, 4, you can put a box around them and change them to 1. So let's see here. I have a -6 and I have 14 i's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm not going to dot all of them. But look what happens. If we take 1, 2, 3, 4 of them, that changes to 1. 1, 2, 3, 4 changes to 1. 1, 2, 3, 4 changes to 1. So these all multiplied together just go to 1. And then we have 2i squared, so that leaves us with -6i squared. All right, now this is higher than 1, so we have to go back to our table here, and we have to change that I squared to -1. So this is -6 times -1, or 6. Now, if we look at the next one here, that's I to the 63rd power. We definitely don't want to write out 63 i's. So what we can do is we can find out how many groups of 4 i's there are in 63. We're going to take 63 and we're going to divide it by 4. So 4 goes in here 1 time. And we're going to subtract to get 23. And 4 goes into 23 5 times. So that's going to be 20. And we have a remainder of 3. Okay, so that means if I were to write out these 63s, I would have 15 groups of 4 i's, and we really don't care about them because they all equal 1. So we don't care about this. What we care about is how many are left over, just like we had over here. We made that an I squared. So we're going to change this I to the 63rd, we're going to change it to I cubed. The problem is it's still too high. So we're going to go over to our table here, and we're going to rewrite I cubed as -I. So I to the 63rd power is -I. So what you want to do is you take your exponent, you divide it by 4. That will give you all the groups of 4 i's. And every group of 4 I changes to 1. So we really don't even care about that. What we care about is how many are left over, just like we wanted to know here. And that's going to be your exponent on I. So when you put that exponent on I, it should either be 1, 2, 3, or 4. If it's higher than 1, you're going to trace it back. In this case, it was cubed, so we change I cubed to -I.